Chapter 4 is a chapter all about congruent triangles. This is where we're going to do our proofs. But we're going to start with 4.1, which is classifying triangles. There are two ways to classify triangles. We can do it either by using their sides or by using their angles. If we classify triangles by their sides, they can be named equilateral, scalene, or isosceles. Try and get the spelling correct. An equilateral triangle is a triangle where all three sides are the same length. And remember, we talked about when you notch the the sides, then that's to indicate that those sides have equal measure. A scalene triangle has no sides the same length, and I want you to get in the habit of not just using your eye, but notice markings. So there's no markings on here to indicate that any sides are the same length. There's also no measurements indicated using numbers. And isosceles is a triangle that has two sides the same length. And drawing it like a teepee is probably the way you first learned isosceles triangles. When I classify triangles by their angles, I can call them equiangular, acute, obtuse, or right. An equiangular triangle has all three angles equal, all the same measure, and once again, that's what we mean when we do this. All three angles would have the same measure. An acute triangle would be a triangle that has all three angles acute. All three angles are acute. Remember, acute means less than 90. An obtuse triangle has one obtuse angle, obtuse meaning greater than 90, and I think we could show that it's right there. And a right triangle is a triangle that has one right angle. A triangle is referred to as regular if it has both equal angle measures and equal side lengths. So the "and" here is important. Equal angles and equal sides. It's called a regular triangle. We refer to it as both equilateral and equiangular. So on your example number 1, to classify the triangle, it's important to remember, what am I asking you to do when I use the word classify? I need for you to give it all of its names. So the triangle is right because it has a right angle, and scalene because no sides are the same length. Example number 2. This looks to be an obtuse, the obtuse angle being right there. Isosceles, two sides that are the same length. An obtuse isosceles triangle. Example number 3. All the angles are acute. They're all less than 90. No sides are the same length. That's an acute scalene triangle. On example number 4, you have all angles less than 90, so it's acute, and two sides have the same measure, so that's isosceles. Example number 5. Again, notice where there is an obtuse angle here, greater than 90 degrees, and no sides are the same. That's obtuse scalene. example number 6, we have one right angle and we have two congruent sides, so that's right isosceles. And now we're going to talk about the triangle sum theorem. Triangle sum theorem says the sum of the interior angles of a triangle is 180 degrees. I don't think this is information that's new to anybody. So for example number 7, it says solve for x, and in order to do that, if you know that the angles are going to add up to 180 degrees, then make an equation that says so. X plus 3x plus 60 equals 180, and then solve that. Combining your like terms, subtracting your 60 on both sides, and dividing through by 4, x is equal to 30. And you could take it one more step, and once you have your x is equal to 30, you could go ahead and solve for this other angle. 3 times 30 then would be 90, and it would be a good way for you to check that all of the angles have to add up to 180. If they do, then you know that you did it correctly. The exterior angles theorem says the measure of the exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. I would like for us to add a diagram to this. So once you get that copied down, the measure of the exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. So let's suppose we had a right triangle. And I told you that this angle up here measured 30. If I were to extend this side, this is referred to as an exterior angle. If I wanted to find the measure of that exterior angle, I know I could add 30 plus 90 and get 120 and subtract that from 180 and get the angle inside here, and then subtract that from 180 to get my exterior angle. But I don't want to do it that way. I know that there's a shortcut. So my shortcut says, if I can remember this exterior angle theorem, that all I have to do to find the measure is to add the value of the two non-adjacent interior angles. What those angles are the two angles that are not next to the given angle, which is this one that we're looking for. So if I wanted to find, I'll call it the measure of angle x. The measure of angle x is going to equal the 90 plus the 30. And I think that you would agree if you did it the other way, the long way around, by finding this first and then subtracting 60 from 180, that it would give you the same thing. So on example number 8, we're looking to find the measure of angle 1. All I'm going to do is say that that must be equal to plus 90, not equals, or 130 degrees. And to find the measure of angle 1, what I'm going to do here is I'm going to say that the 5 5x minus 10 is equal to the 40 plus 3x. So the measure of the exterior angle is going to equal the sum of the two non-adjacent interior angles. And by adding over the 10, and subtracting my 3x, I have 50 is equal to 2x. Dividing both sides by 2, I have x is equal to 25. Now, if x is equal to 25, I'm supposed to be finding what? They're asking me to find the measure of angle 1. I can do this a couple of different ways. I could put the 25 back into the x, where you see 3x. So let me take a different color. Over here, I'm going to say 40 plus 3 times that 25 plus angle 1 is equal to 180. And that would give me 40 plus 75 plus, actually measure angle 1 equals 180. 115 plus the measure of angle 1 equals 180. Subtracting the 115 from both sides is going to give me the measure of angle 1 is equal to 65. Again, I would suggest that when you're doing a problem like this, that you take your answer, which is 65 degrees, and 3 times 25, which we said was 75, and add the 40, the 75, and the 65, and make sure that you do get your 180 degrees. Okay, and that is classifying triangles and finding the exterior angle and the sum of the interior angles of the triangle.